Sometimes you fix a computer just by luck. Other times it's because you know exactly what you're doing. But how do you know that you can do it consistently? Find out more next.
You're watching IT Pro TV.
I've been pretty lucky at times where when I've troubleshooted a particular computer, it was actually fairly easy. And then the next time I go back to that very same computer, and it's really difficult at times. And that's because I don't know exactly what I actually did. But here's a guy that can actually help us out here, which is Mr. Wes Bryan. All right, Wes, when it comes down to it, we need to talk about this idea of a troubleshooting methodology. So where are we going to begin?
You know, Ronnie, we're going to just talk about a few processes that you can bundle together so that you have that systematic approach, that step-by-step approach that you can repeat, a repeatable approach to tackling problems as they come your way.
All right, sounds actually great, and we need to get started, so head on over to the bench.
All right, everyone, come on over here and join me, and let's dive into some troubleshooting methodology. It would behoove you that if you are in a certification endeavor that you should know these steps. It's important. You should also know the adjacencies of the steps as well. So if you happen to see that we're in step 4 and a scenario on the exam hits you with step 4, you should know what the next step is, and that's going to be very important. Those of you that are already in support roles probably already have a detailed process as to what you are supposed to do when tackling certain situations. So some of you might already be familiar with this, right? You might already have an approach, and that's great. That's good for you because you have an approach. Tackle it that way, apply it that way, and then written down, after a while it'll become second nature, but until it becomes second nature, you always have that reference point. And that's what we want. When we talk about any troubleshooting methodology is having a repeatable step-by-step approach that we can take to address problems as they come in through the help desk ticketing system, if you will, or if one of your colleagues brings a computer to you and you need to apply some kind of fix or solution, you have that approach every time. Because let me kind of build on what Ronnie introed our episode here with. I have done that. I'm just as guilty. When he was saying that, I'm saying, Ronnie, have you seen the last 5 or 6 computers I've done? Because I'm guilty of that same thing. And what is that? Guilt, if you will. What am I guilty of? Well, I'm guilty of tackling a problem and thinking, oh, well, it's 1, 2, 3, 4, maybe 4 or 5 of these things, and I just hit every single one of them all at once. If something fixes it, I have no clue what happened because I didn't do it. I didn't apply a methodical approach to it, and then sure enough, a month later, that same problem will come in, and I didn't document anything, and now I have to go and maybe hopefully get lucky with the solution again. Well, we don't want to do that. And that's why we're tackling this here in this episode today. All right, and one of the first things that we really have to do is have to identify the problem. All right, there's a lot of subtleties in between these, by the way. Let's just make you aware of that. And again, if you're sitting an exam, you should be able to identify these. All right, it's important, right? So when we talk about identifying the problems, what are we talking about? Well, identifying the problems here is a real good start for gathering information, right? We want to get into the information gathering, right? We want to question our end users. Why do we want to gather information? Well, we need to be able to know what it is that is manifesting itself. And to do that, we need to do things like, what is the current state of maybe our network, right? We don't know at this point, right? What's the current state of the device itself? All right, has anything changed? Questioning the end user, asking the right questions. End user feedback is essential. Why? Because the user experience can help you to identify what that problem is. When you identify that problem, it's important to ask open-ended questions as well. Don't ask the yes or no questions. Is it broke? Yes. Is it working? No. Well, it doesn't really give you a lot of additional information that you can gather. Have you noticed anything that has changed since this problem manifested itself? That's a little bit different of approach, right, Ronnie? Now, if I was to ask somebody like that, they can give me more information rather than yes or no, right?
Yeah, what we're really looking for, of course, is that ability to isolate down what the issue could be. So we're really defining the scope of what the issue could be at this point by asking those questions. If not, if we only get yes or no answers, that doesn't help because it's so general that they were able to actually give us a blanket answer. So by actually saying, hey, what did change on your computer that you noticed before it actually worked? Did you see an update come across? Did you actually click on anything? Did you install a new program? All those then can lead you down to isolating it a little bit more, where now troubleshooting becomes much more effective. So without that process of you being able to get more information, that means you have to be able to dig at least to your users to go beyond the surface of those questions to try and see what you can find out. So that's probably the primary way that we are first going to have to deal with troubleshooting, because the end users who it is experiencing that particular issue, and you've got to get as much information from them as possible. Okay, so Wes, in terms of that, once we actually have figured that out a little bit more, we of course can gather information from anywhere. We can look on the computer, but what actually happens after that point, once we actually start getting the information that we need?
Yeah, Ronnie. So once we've got that information, we've looked at the computer, like you said, maybe we've got some event logs that we've looked at, we've got our user feedback, and now we start to build that picture in our mind's eye as to what's going on. Well, you're already into the next step, and that step is establishing your theory. Now, I want you to understand, don't just establish a single theory, right? Because then you're going to have to go back to they say, go back to the drawing board again. Well, go to the drawing board and establish a few theories, because then what you can do is you can use your experience, you can use your documentation, you can use the information that you've gathered to start knocking them one off at a time off of your checklist. The big thing with this though is they say question the obvious, right? Simple fixes first. I don't have power on my computer. Ronnie, I don't know that I should admit this to the camera, but I have done that before and going, man, what's going on? The power strip. I set my big size 13 shoes down on the power strip and kicked the power strip off, and that's all it was. It was a little, just turn the power switch back on, and it's good. Now, it doesn't mean that every fix is going to be that easy.
Right.
But go into that mindset. And if you're in the exam booth, think of that mindset too. Because they might wonder, are you questioning the obvious? I don't have any power on my monitor. Did you turn it on? And again, that's not talking down to anybody, but sometimes those fixes are just that simple. Is the cable plugged in? Do you have a loose cable? Can you unplug the cable and look at the connector? And I know with like things like HDMI today, it's becoming a thing of the past, right? More back in the days of things like VGA and stuff. Would you see bent pins, right? And maybe a connector, or maybe something on a motherboard that you can see the obvious, maybe a swelling capacitor, right? So definitely look at some of the simple fixes first, right? And consider multiple approaches, right? Because then you can systematically knock them off a checklist, and then you can move into that next step.
Yeah, when it comes down to that establishing a theory, we want to have at least, let's say, 2 or 3, right? Because we can come up with 15. That's not going to be helpful. What we want is to be able to whittle that down to a possibility of 2 or 3 of those as being what we believe is the first choice that we would go with there. And the reason why we want that, right, is because that gives us a path that we can follow. After a while, if those don't work, of course, you have other theories you can come back to. But if they are, you actually now have a path to move forward. So Wes, once we actually have that theory established, well, what do we do next?
All right, it's time to get on the lab coats, right, and get out our measuring tape. And no, I'm just kidding. What we do is we test the theory, right? And that's what, once you have established your theories, now you go back and you test your theories. And if the first theory doesn't work, that's fine. But like Ronnie said, you got 2 in your back pocket that you're going to go to next, and you test the next theory, right? The interesting thing is make sure that you utilize the resources you have at your disposal, right? Is this a misconfiguration? Well, if it's a misconfiguration, what was configured? What did change, right? Is it defective hardware? I don't know, right? Is it cable issues? Is it a software issue? Remember to use what you have at your disposal when you are testing those theories.
Yeah, when it comes down to testing, test only one theory at a time.
Yes.
Okay? That's kind of key. It happens this way for me, Wes, which is I'll go, oh, that didn't work. but I've already changed a couple of things. And then my mind automatically says, oh, I'll just try what I was thinking to do next. Well, I already made one test. I'm essentially not just testing what originally might have happened. I'm testing also the changes that I just introduced in the previous test. And then when the second one fails, then I try a third one. I may be compounding a problem. So between each test, if it doesn't work, put things back if you actually changed any configuration. Make sure you actually set that up, because if not, you will be testing a different problem than what you think you're testing. And that can become embarrassing when now you go, well, what actually happened? And then somebody else walks and says, all these changes is what the issue is, and they put it back, and then they actually move forward and they fix it. Then you kind of, oh, I caused more of a problem. So that can actually be a bit embarrassing at times when you start doing that. But it actually takes more time, which of course is a waste of time for us. So once we've actually tested that, okay, we really don't actually implement anything permanent at that point, right?
That's right. The next phase is going to become the establishing a plan of action. That's really, really important, right? And you could say a subset of that is actually implementing the action plan, but you got to plan accordingly. And why do I say that, right? Well, should you implement a fix during peak hours, during business hours? Is this something that they say, well, hold on, let's get you a loaner computer that you can use for this afternoon, and we can implement the solution on the computer that we have that's got the problem, right? Rather than just saying, all right, let's go ahead and just implement this, and now the person's waiting around for 2 hours with nothing to do. And that could be okay. I'm not sure. I'm not the judge of that, but you might have a business policy that says, this is when these things happen. This is the systematic approach that once you find the problem, you need to maybe submit a change ticket, right? That says, okay, yes, I can make this change. So the establishment of a plan of action or an action plan, right? When are we going to implement this? And then part of that step as well is going to be the implementation of that plan likewise too. But remember, it's not like our home network, especially when you're talking about in an enterprise level environment. It's not like your home networks. Oh, I think there's something wrong. Well, I'm just going to go reach out and fix it, right? The computer or the system that you might fix might touch, the hands of multiple people. Do you have more than one user? Are you only affecting the one user that's logged into that computer, or is that computer being logged into by multiple people during different shifts? So again, you have to think accordingly. It's not like our own home networks, right, where we can just do what we want. We have to keep in mind that we might have corporate policies that we have to follow as well.
Right. So once we actually have figured that out, where we established a plan that we need, how do we actually say things are actually done?
I would say that's by verifying that we have full system functionality. It is important to make sure that once you have fixed it, that the end user as well believes that it's fixed. That's very, very important, and something that was told to me very early on. Just because you know you fixed it doesn't mean the end user knows, right? And they don't have to. That's why they came to you. You're the professional, not them. Right? That's why they're saying, help me, I need help, right? So it's up to you to provide that help, but it's also up to you to provide that feedback in a way that they understand and let them test drive it. All right, Miss Smith, sit down and type on your keyboard. How does everything feel? Does the new keyboard, have that new car smell? Does it feel right? Maybe you had to replace the keyboard. I've seen that where the whole keyboard shorts out, right? Maybe you got to replace a keyboard, right? Whatever it might be. Make sure that the end user verifies that they have the functionality that they expect, because then at the end of the day, they're the ones that you're trying to help. So verify full system functionality, and I would also encourage you to make sure that the end user feels that what they've brought their device to you to get fixed, that they feel satisfied and confident that the fix is there.
Yeah. Now, Wes, one of the issues that I always have is simple, that even if I fix something, and let's say it's a multi-step process to something, I always believe I'm going to remember this. And then it happens to me, let's say a week or 2 weeks later, I go, I know exactly what happened because I just fixed this 2 weeks ago, and I can't even remember where I started, Wes. It's kind of a big problem at times, right?
It is, and it is. If I had $1 for every time that I forgot to do this, I'd be rich right now, and that's documentation. You cannot say it enough. When you are finished with verifying system functionality, document your entire findings. Document the problem that was addressed. Document the symptoms. document the solution. Document that you verified with the customer that the system is up and running and what they expect. It might be required. It might be something that you have a ticketing system and that's required to finish the ticket and move on to the next job, right? But even if not, for your own benefit, I remember, Ronnie, I looked in recently at some of the old Dell machines that I used to support, and I opened up the old service numbers. There's one in there I don't ever remember even touching. Like you said, I thought I would remember that. I don't even remember actually touching the machine, but that's because it's IT. It's a fast-paced environment. And one of the great things that your documentation does is a blueprint of your experience as well. It's something that you can use almost like a work-type journal. You can reference back. I have tackled situations, and again, I'm guilty of this. I shouldn't be admitting this, but learn from my experience, like Ronnie admonished you too, that I have tackled the same problem, and the second time I had to tackle it, it went just as long as the first. If I would have just documented it at the time that I was fixing it, when I fixed that problem, I'd have a reference point to go back to right away, and it would have made it a whole lot easier. Remember these steps if you're sitting the certification exam. Also remember the steps if you're in a support role or a help desk environment. It might be required of you already. If you can do that, you're going to be doing very good.
Thank you for watching IT Pro TV.
Everybody feels bad at times when they get ill, but what could actually be wrong? How does that relate to computer repair? Let's find out more next.
You're watching IT Pro TV.
Welcome back to the show. Yep, that's right. The first step to actually being able to troubleshoot a component and repair it is going to be to identify the proper one and what it can actually be. Now, Wes, a lot of times when we actually have issues, the symptoms are all the same. How do we actually begin to isolate that? So how are we going to tackle this?
So, I was wondering that myself, Ronnie, when it come down to it. We were looking at some of the symptoms when it comes to PC components, and one of the things that you've kind of hinted at is the fact that there kind of be, some of the problems can be across multiple components, and they can really manifest themselves in the same way. So we're going to, what I figured what we would do is we would look at the four main components within the PC that we have to talk about. Motherboard, we're going to look at the CPU, the RAM, and the power supply unit, because when it comes down to the general symptoms, a lot of times they're going to be the same across the board. So we're going to talk about some of the symptoms that you can see, as well as some of the things that we can keep in mind when it comes to repairing or troubleshooting these.
All right, Wes, I see a lot of different components out there. Let's head on over to the bench.
All right, everyone, come on over here and join me. And this is another one of my favorite episodes because of the fact that, well, we get to look at hardware, right? Hardware is important. And in this episode, what we're going to do is we're going to start by tackling motherboards first. Now, when it comes to motherboards, some of the things that we have to keep in mind are, well, going out the gate, I would say first we have to worry about things like swollen capacitors. So let's go ahead and take a really close-up look, right? When we look at a motherboard, there are a series of capacitors all over the motherboard, and these are very, very important capacitors that you see right here. And what I'd like to do is I'm going to take and get you another motherboard and show you that even older motherboards still have those same set of capacitors, right? And we have other ones, but I'm focusing on these because these are really important. These capacitors help to do the voltage regulation, modulation, if you will. They step down the voltages. They make sure that our components that are being powered have the appropriate voltages, because in our power supplies, remember, we have 5 volts, 12 volts, and 3.3 volts. But when you look at something like a DDR4 RAM module, it's really only using around 1.5 volts. So what is helping us to regulate the power across the motherboard? A lot of times it's going to be those capacitors. So a telltale sign that your motherboard has failed or is about to fail is if you look at one of these capacitors and you notice that they're swelling. Another thing that you might find out is you might smell some burning smell, and you might actually see a little darkened color on top of the capacitors too. Other things that we have to worry about are things like socket, and slot damage, right? And this can happen if you're trying to install the inappropriate memory. Remember that the notches are there for a reason, and if you try to install it backwards, you could crack the slots. Same thing goes with your expansion cards too. You have to be very careful and make sure that you're installing these appropriately, because we have all of these massive little traces. You can see those little highways, right? And it doesn't take much to break one of those highways. The other thing I'm going to mention too, and Ronnie, I didn't put this in the notes, but we also have, when we mount these motherboards to the inside of the case, usually what we have are standoffs on the case. So it's just a little raised screw that helps to make sure that the bottom of the motherboard isn't sitting directly on the case wall. Well, if you don't put the standoffs right and you, let's say, leave one out, there is a potential that your motherboard could touch the inside of the case and we could have some electrical arcs, right? We use, another thing I want you to keep in mind too is we have the I/O panel, right? It is good to have the I/O panel because we got a lot of integrated functionality that we do not have to worry about installing additional cards. Well, these ports can go bad as well too. So you have to pay attention. Is there any damage to any of the I/O ports on the back of the panel likewise?
Yeah, along with that, right, when we talk about capacitors, this is probably one of the things you won't actually get to very often. Most capacitors today, they actually handle the load fairly well, and the power supplies have gotten better over time. But the way that you could actually tell in terms of the swelling is that you wouldn't actually look for it to kind of bubble out. What you look for is the top of that capacitor to essentially kind of either bubble up, or you might see it leaking. Anytime you actually go, hey, that looks a little bit oily on the inside of your motherboard, there probably is going to be a capacitor issue, and so your board is not going to function the way that you think it is. And that's usually a bad day because, well, we don't tend to re-solder capacitors back on. Wes, when we have a bad capacitor, there is only really one fix to that, which is going to be what?
That's going to be replacing the motherboard. It's a good point. One of the things that I've used in the past, Ronnie, too, is a little pencil eraser and kind of erase. I know it sounds weird, but you kind of erase the top of the capacitor. And when you look at the eraser, you could see burn marks, right? You could see some of those leaking metals. I don't recommend getting any of that on your hand. Now, what's also interesting, too, is that you might find a point in time when your system is no longer keeping accurate date and time. Let me show you what that's about, right? This little battery here, we typically call this a CMOS battery. I'll tell you today, though, we're not really using it like we were in the earlier days. In the earlier days, when we had things like EEPROM chips, these batteries might store additional BIOS configurations. However, really today, we're using EEPROM. Software can store BIOS settings in non-volatile memory, and when we reboot the computer, since it's non-volatile, those settings stay behind. However, one of the things that we haven't been able to do is manage to maintain a real-time clock in non-volatile memory. So today you'll hear what's called RTC. That's just short for the real-time clock. And if this battery is a little, help me out, Ronnie. This is the 3032, I believe, right? 2032, yep. 3-volt CMOS battery, and it today stores the real-time clock. If that battery fails, then what you're going to notice is every time you reboot the computer, the time is going to be off. And it's important to have your real-time clock needs to be accurate. It not only sets the heartbeat for the entire computer and the traffic that's going across the motherboard, but it also helps too with network communications to synchronize communications as well. So that's going to be very important, and those are some of the things that I would be able to be aware of, be able to identify. Another telltale sign that you have some issue really with any of these components, but we'll go ahead and mention here in the motherboard, is listening for post beeps. When you push your power on your computer, you should hear one beep. That is a post beep letting you know that the power on self-test found all of the hardware that was connected to the motherboard, and we're ready to go, and we're ready to look for an operating system to bootstrap the hardware.
With the idea of the post beeps and also with the timing that you were talking about, the very fact is timing is a very important component when we start to get into more enterprise level types of networks as well, where there has to be, of course, certain timing to actually ensure that the authentication is actually kept real as well. So if your computer goes out of time by more than 5 minutes compared to the other devices that it needs to, you're going to see you're going to get kicked off, you're going to get locked out of resources. And when we were talking about the other thing that you were talking about here, Wes, the post beeps, this is something that you do need to listen for. There are times when you put in components or you change something, and as soon as you reboot, If you hear anything different than that one beep, than what you actually normally hear, that lets you know that there is a physical hardware problem and you need to address it. Whatever you change, put it back and then see if you actually get the one beep again. If you do, then you realize you put some wrong component or you actually have some wrong setting there that shouldn't be that way.
Yeah, Ronnie, and keep me honest. Remind me to double back on that same thing when we tackle RAM, because there's some things that we've seen related to that CMOS battery when it comes to RAM. So that's a little bit about the motherboard, and I do want to mention socket damage of your motherboard, and that kind of moves us into the next topic. When we talk about motherboards, we talk about CPUs, but this could be in between CPUs and motherboards, really, when it comes down to it. Notice that is a PGA socket right there, and you can see some of the pins, actually this is an LGA, I apologize, this is an LGA based socket. You can see some of the pins within the LAN grid array are actually bent. This motherboard has to be replaced. We can't fix this, right? And that brings us to our next topic, right? We talk about CPUs. CPUs, the central processing unit, remember, it's the brains of the operation, and there are things that we need to make sure are adequate for the system unit as well as properly installed, right? One of the things that you have potential for is overheating, right? Not having proper thermal management, right? The management of the heat. So let me show you here. So I've got an overhead view here. What I've got is I've got a computer opened up, and what I did is I took the heat shroud off of the top of the CPU so that you can see that we have a CPU fan. We also have our heat sink under the CPU. Remember, the heat sink sits on top of the CPU to expand its surface area and dissipate the heat from the CPU into the heat sink, and then the fan provides us with active cooling because it's actively blowing the heat out of the valleys within the heat sink. Now, when you plug in your computer and you turn on your computer here, you're going to see it's going to go through a pre-post. Some of these computers do that, where it actually does a pre-post when you plug it in. What we want to see is we want to make sure that when we turn on our system unit, that our CPU fan is working correctly. But you also have to make sure that we have proper installation, because improper installation is going to cause a problem. And let me show you, if we take a really close look, right, one of the things that is part of our CPU's cooling, along with the heat sink, along with the fan, is what's known as thermal compound, right? When we put thermal compound, we put just a right-sized dot right there in the middle, and then we install the heat sink on top of it, and we screw that down. And as we bolt that down, it literally presses the heat sink into the thermal compound and spreads it across the die of the CPU. Now, that's important. Why is it important? Well, if you get a technician that gets going a little bit too fast and doesn't put the thermal compound, or doesn't put it adequately on there, then you turn your heat sink into an insulator, because you have metal on metal. Well, the thermal compound bridges the gap between the inconsistencies of the metal on top of the die of the CPU and on the bottom of the heat sink. And if this isn't put on properly, then we can have overheating issues too. And by association of that, if you put too much thermal compound on this and you tighten that heat sink down on top of the CPU, you could actually have some of that thermal compound that spills over into the sides, into the socket. Let me tell you, if you've ever had to deal with thermal compound, it is a nightmare to get off of your hands at any component that it gets onto. And if you're using something like, let's say, a higher end thermal compound like Arctic Silver, it's got a lot of metal in it, right? Because metal is a good heat, it transfers heat really well, but it's also a really good conductor of electrical current too. So if you get any excess thermal compound like that down in the board, you don't get just blockage of your electrical contacts. You actually can get an arcing and electrical shock. So one of the things that you want to do is make sure that you have the appropriate fans. And there are a few different types of fans here that I want you to be aware of. So this is a fan. This fan right here is a 120 millimeter fan, and I want you to notice that there's various connector types. This is a 4-pin connector type, and what it allows is it allows the BIOS to compute. It'll be plugged into the motherboard, and it allows the BIOS, or the firmware platform, to detect that the fan's present, detect the RPMs, and what the temperature is inside of the case. But you also have smaller 80 millimeter fans that you could potentially use that you can see have a different type of connector, and that's the 3-pin connector. Now, The good thing about these type of connectors is when they're connected to the headers on the motherboard, again, is the motherboard can monitor the current state of the fan. However, you don't always have fans like that. Sometimes you want to increase the cooling system to help maybe bring the CPU temperature or the internal temperature down in the case. So you might use one of these that actually uses an older connector here. Same system fan, right? Same type of 80 millimeter system fan, but this is actually using the old Molex connector. Now there's a benefit. What's the benefit? Well, the benefit to this is let's go ahead and turn our power supply on, and try that one more time. There we go. You can see a power supply come on. So now our fan's spinning, right? It works just fine. However, I cannot monitor it. We cannot do variable speeds with this because of the fact that it's just connected to a rail on the power supply. Unfortunately, there's no way to monitor that. Good, because you can expand and get sufficient cooling for your system unit. Could be a drawback in the fact that you can't actually monitor these. Now, if these fans start to fail, let me see if I don't know if I'll be able to do this. Hopefully we can. Let's try this one more time. There we go. You hear that click? If you can hear that grinding, sometimes if you have bad cable management, your cables, can you hear that grinding, can get in the way? You might hear a grinding noise too if the fan starts to fail. The fans have bearings in them, and they're only going to last so long. So if you start to hear grinding noises, it could be the fact that you have either a cable that's in the way, poor cable management, and it is knocking on the fan itself. It could be the bearings gone in the fan as well too. So that are some of the things that we need to think of in the cooling systems. And remember, the cooling systems affect all of the components that we're talking about, but I just put them here specifically with a CPU so that we could focus on the relationship to the cooling in the CPU itself.
All right, now, Wes, let's talk about the idea of the improper insertion of that socket again. Mm-hmm. The CPU that you actually showed us, it looks perfectly square, and the socket itself looks perfectly square. Can I actually turn it the wrong way?
You could potentially turn it the wrong way. It's a little bit harder with PGA-based sockets because they have the pins and you're going to bend pins. But if you have like the one that we have here, so for instance, if we look really close, this is an LGA-based socket, right? It's got the lands, the flat contacts. But Ronnie, what you're looking for is this little golden triangle right here. This little golden triangle actually lets you know, and this is a PGA socket that we have here, so I wouldn't be installing this on this board, but whether it's PGA or whether it is LGA, one of the things that they all have in common is a little mark. Now, I know that's kind of hard to see, so if you can see right there, there's a little triangle at the bottom of that socket. And what that lets me know, and again, whether it's a LGA or whether it's a PGA based CPU, all of them will have that little triangle that lets you know how to line it up within the socket. If it's a PGA socket, then you typically have the ZIF socket with a little arm, and when you open that arm up and line it up, there's a reason they call it zero insertion force. You should be able to drop it and it falls right into place, and you don't have to force it, preventing pin bending, and then the arm locking back in place prevents chip creep. The LGA socket, keep in mind, you could put it on wrong and you could cause an electrical short. A lot of times they're going to be notched in a way. So this one even has notches. I didn't point that out. So you see the notches on the bottom here on each side. So they go kind of out of their way to make sure that you cannot install these wrong. But if you don't pay attention to that, that could cause problems. Now, one of the other components that we have to worry about is things like our random access memory. And again, all of these things can manifest themselves really in the same way. So one of the things I want you to keep in mind is that you don't want to have a memory mismatch. And now, if we take an overhead view here, you're going to see that we have two installed modules here within this computer. Now, if I install a module that has a lower speed than another module, remember that it's going to reduce the speed to the slowest common speed of the installed memory. And that's why it's important. Make sure that you have matching memory, matching speed, so that you can take advantage of the performance that you increase that you get of the newer standards. And as well, make sure that you're installing them in the right order in the case, because if you have open RAM slots on the motherboard and you don't install them in the appropriate order, then what you could be doing is taking multi-channel architecture that is there to help increase the speed of the memory and the CPU, the performance, I should say, and what you're doing is reducing it to a single channel memory architecture, and that's not what we want. So pay attention to the memory matching as well. Now, Ronnie made mention of something earlier that said, hey, if we replace a battery or a battery fails and we replace that battery, we might get certain components that aren't recognized. And this happens sometimes either when you change out RAM or you change out that battery. It goes to look for the memory, and the last memory it remembers might not match with what it's seeing right now, and it actually throws a post-error code and prevents you from starting the machine. One of the easiest ways to get around this, just reboot the machine, because now what it'll do is it'll say, okay, now I've rebooted, and last time I seen the memory, this is the memory we have installed, there's a match, we're good to go, and that gets you over that boot process. Also with your RAM, make sure that they're properly seated. Make sure that when you install them, there's a click, all right? You can hear the arms come back up and grab onto the memory. If you do not properly seat them, you might get post errors, or you might actually get audible or visual light errors too. Like, so for instance, this Lenovo that we've been using, when I did our RAM episode, I installed the module, but one side was left up, and when I pushed the power on the computer, went to turn it on, I was getting amber lights and white lights on the front of the power button, and I looked up the codes, and that let me know that it was improperly seated memory. We take the memory out, we reseat it, and that's gonna that should fix that problem. All right, Ronnie, so we've gone through motherboards, we've gone through CPU, we've gone through RAM. One of the last things I'd like to tackle when it comes to components is a power supply. Now, big disclaimer, power supplies fail, replace them. All right, there are capacitors in these power supplies that hold enough amperage that if you open them up and touch them, they could kill you. All right, do not open these power supplies. There is nothing in a computer that is more valuable than you are. So be careful, all right? There are things that you can do. You can use one of these components potentially if you need to test power supplies. This is a multimeter, all right? However, keep in mind you have to you have to set it to the appropriate voltages, or you could fry the multimeter too. What I like and what I've been using here is this component here. Let me move this motherboard out of the way and show you here. It doesn't look like much, but this is a ATX power supply tester. All right, and what it allows me to do is take the power supply. This power supply is completely out of the case and it's running right now. All right, your motherboard, if you do not have the power supply connected to the motherboard, it should not turn on. However, what this is doing is I've got the 24-pin connector plugged into the bottom, and it's letting me know that I have the 5-volt rail, and you can see the 12-volt rail. It's within its tolerances, but it's a little less than 12 volts, and the 3-volt rail as well. But notice that I've got different connectors. Here we have our 8-pin CPU power connector. We also have our CPU connector. This is PCIe connector too. What I've got connected currently to this power supply is a serial ATA connector. So let me turn this back on, and let me switch this over, and look at it one more time. And I know it's kind of hard to see right there, but that says SATA, right? That's SATA, serial ATA. And I can see the 5-volt rail, I can see the 12-volt rail right there, and I can see the 3-volt rail. Let me show you what happens if it wasn't performing adequately. Ronnie, all I did is I pulled that out a little bit, and notice it's going, hey, I don't know what's going on. I can still detect that there's the 12-volt rail is there, but that's how you can tell. And you can, let me just be quiet here. And you can hear that beep, and it's letting me know that something's wrong. Now, I did that on purpose, transparency. But if one of those other wires, cables within that connection fail, then you would be able to detect that. And I like the ATX testers. This is one by Thermaltake, because it offers you a level of safety. You have to be careful with the multimeters. So some of the things that you could you have to worry about when it comes to the power supply units, remember that if they're fixed input power supply, which is becoming more of a legacy type thing, remember you have to make sure that they're fixed to the appropriate voltages. If you're here in the United States, you're going to fix it to the 115 setting. If you happen to be in the European countries where they're using 220, you're going to fix it to the 220. Keep in mind that if you put something on the selector switch on a 115 setting and you connect it to a 220 outlet, you are going to fry the computer. The reverse is true if you have it set for 220 and you connect it to a 115 outlet. You're going to be underpowering the system, and anytime you have undervoltage, you're going to cause system instabilities, let alone if the power supply has failed. So those are some of the things that I would worry about when it comes to the power supply units as well there, Ronnie.
Yeah, so there's actually, of course, since you've actually gone through all of them, we've kind of hit a lot of these different topics. Are there any other symptoms that we want to address?
Yeah, not really. Just, remember, we've talked a little bit about the burning smells. Those are obvious, signs, the grinding noises. So remember, simple fixes first: visual, audible, can I hear it? Swelling capacitors. Remember that a lot of all of these components start to fail. Any one of them, you could start to get crashes, blue screens, if you will. Maybe intermittent reboots if your computer starts to overheat. Sluggish performance, as well as, remember your postcode beeps. Those are going to be important too. These are some of the general symptoms across all of the components that we've talked about.
Wes, what about some of the other tools that we can use to help us to begin troubleshooting issues?
Yeah, Ronnie, there are a couple of things that I didn't mention, and one I should have mentioned when it comes to overheating. A tried and true thing is compressed air. Remember that when you talk about overheating, pay attention to your vents and your fans, and just generally inside of the case, a little bit of compressed air, small little burst, right? And that can help, clear up the vents when it comes to overheating. Another way that another couple of pieces of software that I would recommend you having is one that actually monitors voltages and temperatures within your systems, as well as tools that help to diagnose CPU issues, and then also certain diagnostics that you can run on your RAM too. Let me show you what I mean. So I have something in here called HW Monitor, and HW Monitor, short for Hardware Monitor, is a really, really good program that I like because it lets you to see what the current voltages are, what the utilization of the components that we've been talking about in the system, what are the temperatures, right? It detects temperature. Again, what is your clock speeds? You can see utilization here. We can see, for instance, our solid state disk drive. What is the temperature? What's the activity? Our GPUs as well. What are the temperatures of our GPUs, as well as things like our integrated graphics. And again, a lot of good information that you could use here to kind of figure out, are the temperatures, are the voltages where you need to be? And if they're not within the tolerable ranges that you see that are specified by the vendor, then you can get into some of the troubleshooting on why those voltages aren't where they're supposed to be, or why the temperatures aren't where they're supposed to be. So that's a really good piece of software. I've got another one here, and this is specific to Intel-based processors. It is an Intel processor diagnostic tool, and what it'll do is it'll run your CPU through a variety of tests. And what we should see, there we go, you'll see that it's doing a graphics test, and it's trying to detect how can it render, and is it passing these tests as it makes various passes. I've actually got, let me show you here. I've got the results of a test, because it could take a while depending on how many things it's checking, right? So it's checking for some of the multimedia extensions and cache, if you will. And you can just find out. It does a stress test on it and finds out if it passes. And then you can compare this back to what the current temperatures are that you're seeing in something like HW Monitor, and that would give you the ability to find out, hey, are we actually having issues, and how can we diagnose those? One of the last things I want to mention is inside of Windows, you have your Windows Memory Diagnostic Kit or tool that you could run as well. I'm going to go ahead and cancel this one, Ronnie, so it's not bogging my system down. And this allows me to do some checking for memory problems, right? We could check for memory errors. Now, it schedules it. It allows you to either restart it now. If you don't want to restart the computer, what you can do is you can say, check for problems next time I restart. And what it's going to do is it's going to put a little flag in the boot manager that says, hey, before you boot the operating system, actually load this utility in the pre-boot phase, and let's run some tests on the memory itself and find out if we have issues. So those, Ronnie, are some of those additional utilities that you can use when it comes to diagnosing your various pieces of hardware that can help you find out what are some of the issues that we're having. Remember, find out what the symptoms are, use your troubleshooting to diagnose what the potential cause is, and that's going to, at the end of the day, help set you up for success and a potential solution.
Thank you for watching IT Pro TV.